Hi everyone, today's topic is binomial theorem. What is binomial theorem and why we have to apply the binomial theorem? We are going to see today. So binomial theorem. So binomial. What is binomial expression? A binomial expression is expression formed by two distinct terms. So two distinct terms. So bi is nothing but 2. For example, x plus y, a plus b. So these are the two distinct terms that forms the binomial expressions. So before going to the binomial theorem, let us discuss some important terms which are required for the binomial theorem. So what is factorial? So factorial is nothing but the product of the first n natural numbers. Now if I take n factorial, the formula is n into n minus 1 into n minus 2 into so on 3 into 2 into 1. Now if we take this formula and go for 5 factorial, 4 factorial, 4 into 3 into 2 into 1. So if we go for 5 factorial, 5 into 4 into 3 into 2 into 1. So if you observe here, we can write this the product 1 to 4 as 4 factorial. 5 into 4 factorial because these two both are same. So we substitute as 5 into 4 factorial. Based on this, we have some important result. So nothing but n factorial is equal to n into n minus 1 factorial. And another important result we have to remember, 0 factorial is equal to 1. And another important formula for binomial theorem is NCR is equal to n factorial by n minus r factorial into r factorial, where n is a natural number and r is whole number and n is greater than or equal to r, where r should not be greater than n. Now a plus b whole square is equal to a square plus b 2ab plus b square, and a plus b whole cube formula is a cube plus 3a square b plus 3ab square plus b cube. Now a plus b whole power 4 formula. So now we face the difficulty to split the terms. So here the binomial theorem importance arises. So if you see, we can write it as a plus b whole cube into a plus b, a cube plus 3a square b plus 3ab square plus b cube is the formula of a plus b whole cube, and a into a plus b. Now multiply a power 4, a into a cube, a power 4, a into 3a square b, 3a cube b, a into 3ab square, 3a square b square, a into b cube, ab cube plus b into a cube b, b into 3a square b, 3a square b square, b into 3ab square, 3ab cube plus b into b cube, b power 4. So now if you see here, add the similar terms, a power 4, 3a cube b and a cube b, 4 a cube b. Now 3a square b square, 3a square b square, 6a square b square. Next ab cube terms, ab cube 4 ab cube plus, now what is the remaining, b power 4. So if you observe carefully, we can notice some similar things. So compare this index here. So what is the index of a plus b whole square? 2. Count the number of terms, 1, 2, 3. So index is 2 and the number of terms are 3 in the expansion. Now if we consider a plus b whole cube, the index is 3 and the number of terms 1, 2, 3, 4. So the number of terms are 4. If we consider here a plus b whole power 4, the index is 4 and count the number of terms 1, 2, 3, 4, 5. So whenever the index is n, the number of terms are n plus 1. So this is the first thing. Index is equal to n, then number of terms is equal to n plus 1. Next, second observation. Now if we observe here the power of 2, here first it is 2, next 1, next 0. So the powers of a are in decreasing order, 2 1 0. Here a cube power 3, a square power 2, here a power 1, here a power 0. So a is decreasing, and if you see for b similarly, here there is no b, so the power is 0 1 and 2, so b is increasing. If you see here also, b is 0 1 2 3. So this is the second one. And third observation, if you see the terms, each term the power is 2, and here a power is 1 and b power is 1. So 1 plus 1 2, here b here term b square power is 2, so 2, here also 2, here also 2, and here a power 3, a power 2 and b power 1, 2 plus 1 3, here the power is 3, and here the total power is 3, here 1 plus 2, the total power is 3, here also the total power is 3. If you observe the similarity here, the powers are 2, which is equal to the index of a plus b whole square. Here also the sum of the powers of each term is 3 3 3 3. So if I take terms, if I add them, we get n as index. So these are the three important things that we have to observe here. Now Pascal's triangle. So what is Pascal's triangle? Pascal's triangle is nothing but a triangle formed by the coefficients of the binomial expansion. So if I take the binomial expression as x plus y, let the index be 0, then coefficients will be 1. Now if I take the index as 1, the coefficients will be 1. So if I take here, see, x plus y whole power 0, index is 0 1, so the coefficient is 1. Next, x plus y whole power 1, if I am taking the index as 1, so the coefficients will be 1 and 1. Now if I take the index of x plus y 2, then 1 1 plus 1 2 and 1. Now if I take x plus y whole square, x square plus 2xy plus y square is the expansion of x plus y whole square. So where if we compare the coefficients of this Pascal's triangle when index is 2, the coefficients are 1 2 1 1 2 1. Now if I take the index as 3, 1 1 plus 2 3, 2 plus 1 3 and 1. Now compare this, whenever the index is 3, the expansion, if you go here a plus b whole cube, the expansion, index is 3, expansion is 1 3 3 1. So the expansion consists of the quotients 1 3 3 1, so 1 3 3 1. Now if I take x plus y coefficient as 4, we have to get 1 4 6 4 and 1 as the coefficients in the Pascal's triangle. Now 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, and take it as 1. Now the coefficients what we have got here, 1 4 6 4 1, 1 4 6 4 1. So this is what the Pascal's triangle.
Now let us see the expansion using binomial theorem. X plus y whole power n is equal to nc0 x power n, nc1 x power n minus 1 y power 1. So whatever the term is in r place, we get it as the power of y. So as the power of y is 0, so it is 1. So the power y term is missing here. Next, the term in place of r is 1, so the power of y is also 1. Similarly, nc2 x power n minus 2 y power 2, so on ncn y power n. As the power of x is 0, we get only y power n. Now if there is x minus y whole power n, we take it as x plus of minus y whole power n. If we expand this, we get nc0 x power n plus nc1 x power n minus 1 minus y whole power 1, as the power will be the same as term in r place. Now nc2 x power n minus 2 y power minus y power 2 plus so on ncn x power n minus n is 0, x power 0, so it is 1, so minus y whole power n. Now if you see here, we can write it as nc0 x power n plus nc1 x power n minus 1. Now if you see here, as the power is odd, it can be written as minus, so minus y. So here it is even power, so we get nc2 x power n minus 2 y square. So wherever the odd terms are there, we get the minus symbol outside. So here ncn minus y whole power n. As we don't know the power whether it is odd or even, so we keep it as it is. So this is for the binomial expansion.
Now let us derive the formulas using binomial theorem. A plus b whole square is equal to 2c0 a power 2 minus 0 b power 0 plus 2c1 a power 2 minus 1 b power 1 plus 2c2 a power 2 minus 2 b power 2. Now we know that nc0 is equal to 1, nc1 is equal to n, and ncn is equal to 1, and ncr is equal to ncn minus r. So these are the required formulas. Now 2c0 is nc0 is value is 1, so it is 1, so a power 2 minus 0 is a square, b power 0 is 1, so leave it as it is. 2c1 is nc1 is equal to n, so 2, a power 2 minus 1 a, b power 1 b, 2c2 ncn is equal to 1, so 2c2 value is 1, so leave it. Next, a power 2 minus 2 0, 2 minus 2 is 0, so a power 0 1, so leave it b square. So this is the formula we derived from the binomial theorem. Next, a plus b whole cube is equal to 3c0 a power 3 minus 0 b power 0 plus 3c1 a power 3 minus 1 b power 1 plus 3c2 a power 3 minus 2 b power 2 plus 3c3 a power 3c3 a power 3 minus 3 b power 3. So now 3c0 is 1, a cube, b0 is 1, b power 0 is 1, 3c1 3, a power 2 b. Next, 3c2 value is nothing but 3c1, so 3c2 as per this formula ncr is equal to ncn minus r, so 3c2, so 3c2 will be is equal to 3c1, since 3c2 is equal to 3c1. Now 3c2 value is 3. Next, a power 1 b square plus 3c3 value is ncn value 1, So as similarly 3c3 value is 1, a power 0 is 1, so b cube. So we get a cube plus 3a square b plus 3ab square plus b cube. So this is the formula we derived from the binomial theorem. Next, a plus b whole power 4 is equal to 4c0, a power 4, b power 0, 4c1, a power 3, b power 1 plus 4c2, a power 4 minus 2, 2, b power 2 plus 4c3, a power 4 minus 3, 1, b power 3 plus 4c4, a power 4 minus 4, a power 0, so value is 1. Next, b power 4. So now if we see here, nc0 value is 1, so a power 4, b power 0 value is 1, so leave it. Next, 4c1 4, a cube b plus 4c2, so 4c2 value is 4 into 3 by 2 into 1, 2 2s are 2 3s are 6, so 4c2 value is 6, a square b square plus 4c3 value is nothing but 4c1. NCR, using this formula, NCR is equal to NC n minus R. So 4c3 is 4c, 4 minus 1, 4 minus 3, 4c1. 4c1 value is 4. So 4a b cube plus 4c4 is NCN value is 1. So 4c4 value is 1. Take b power 4. So this is the way you derive the binomial expansions.